Hello, juniors. Today we're going to start with a new chapter of the book, which has to do with geometry and trigonometry. This corresponds to chapter 11 of our book. And today, specifically, we're going to see something that you should have already seen in previous years, and this is considered prior knowledge for the IB program. So it says the geometry of 3D shapes. Objectives: find the midpoint between 2 points in space, find distance between 2 points in space, find surface area of different geometrical figures such as prisms, pyramids, cones, and spheres, and finally find volume of different geometrical figures such as prisms, pyramids, cones, and spheres. Okay, so if you remember from previous years, we had a midpoint formula, which midpoint is basically we have a point A and a point B. The midpoint is the point that is in the middle, right? And the mid distance between these two, maybe around here, would be the value M, which is the midpoint, right? Let's do this in a different color. So that's the midpoint. We usually represent it with a capital M. Okay, so how do we find the coordinates of the midpoint? Basically, it's just finding the average between the coordinates, the X, Y, and Z coordinates in case we're talking about 3D figures or three-dimensional points. It's the average between the coordinates of each of the points, okay? x1 plus x2 divided by 2, y1 plus y2 divided by 2, and c1 plus c2 divided by 2. So that's the midpoint formula. In case we're talking about 2D points, 2 dimensions, we just discard this term and we find the midpoint for x and y. Okay, then we have the distance formula, and here's a brief demonstration of where the distance formula comes from, but since this is very basic, I won't waste too much time showing where this formula comes from, but it's basically applying the Pythagorean theorem from a triangle, right? So this is the formula for distance. It says the distance d between 2 points in space is given by this formula over here. It's the square root of x2 minus x1 squared plus y2 minus y1 squared plus c2 minus z1 squared. This basically corresponds to applying the Pythagorean theorem of a triangle, in this case in 3D, right? But it's just a Pythagorean theorem. Okay, then it says hint. AB, like this, is used to denote the line segment with endpoints A and B. AB without the brackets is used to denote the length of the segment AB. So when we say find AB, we are asking for the length of the segment AB. Or we could say find the length of segment AB or find the length AB. Those are all synonyms. Okay, so let's see this short example just to remember this concept. It says find the midpoint and length of the segment AB when A has these coordinates x, y, z, and B has these coordinates x, y, z. Okay, so first of all, we want to find the midpoint. So we're going to write midpoint. We could write it like this, between A and B. And this is given by the average between the coordinates, right? So this would be basically the x coordinate would be 1 plus 3 divided by 2, comma. The y coordinate would be 2 plus 3 divided by 2, comma, and the c coordinate would be 5 plus 7 divided by 2. Okay, so if we solve this, we're going to get the midpoint. Let me copy this. We're going to get that the midpoint is equal to 1 plus 3 is 4 divided by 2, that's 2, right? So 2, comma. 2 plus 3, that's 5. 5 divided by 2 is 5 over 2, which is 2.5. So we can write it as 2.5 or 5 over 2, same thing. 5 plus 7, that's 12. 12 divided by 2, that's 6. So these are the coordinates of the midpoint, basically. Then we want to find the distance between the 2 points, right? Find the midpoint and length, right? If we're asked for the length, we're asked for the distance. So let me do that right here. I'm going to say that distance between point A and B is given by, and we have the formula, the square root of x1, 1 minus 3 squared, x1 minus x2 squared plus y1 minus y2 squared plus z1 minus z2 squared. So if we solve this, we're going to get the distance which in this case would be, let me do this with calculator directly. This would be the square root of 2 squared plus 2 squared plus 1 squared plus 2 squared. I get 3. So the distance between these 2 points is 3. Okay, so that's midpoint and distance. First basic concept that you need to know for this chapter. Okay, then we have pyramids, cones, and spheres. It says the base of a pyramid is a polygon, and the 3 or more triangular faces of the pyramid meet at a point known as the apex. In a right angle pyramid, the apex is vertically above the center of the base. So here you have the apex is where all the lateral faces meet, and the base is the floor of this figure, right? It says the figure on the left is a square-based pyramid, but there are also tetrahedrons, which is this case. What does this mean? It means that it is a triangular-based pyramid, and hexagonal-based pyramids, and so on. So we have different pyramids depending on the base, basically, on the number of sides of the base. Okay, then it says, there is a close relationship between pyramids and cones. The base of a cone is a circle rather than a polygon, so it does not have triangular faces. So a cone, we could say that the cone is a particular case of a pyramid, right? The only difference is that the base is a circle instead of being any other polygon, right? Then it says, a sphere is defined as the set of all points in three-dimensional space that are equidistant. Equidistant means same distance from a central point. Half of a sphere is called a hemisphere. This is very important for you to remember. So here you have the hemisphere. Okay, then we have surface area and volume. The surface area of any 3D figure is the sum of the areas of all of its faces, right? And the volume, let me change this to red. The volume the volume of any 3D figure is a space enclosed by a boundary or occupied by an object. Okay, so here we have the formulas for surface area and volume of these 3 particular figures, pyramid, cone, and sphere. For a pyramid, it says the sum of all of the faces, x squared plus 2xl for a square-based pyramid, where x is the length of the sides of the square base and L is the slant height. So this formula actually changes depending on the type of pyramid, right? In this example, this is the formula for a square-based pyramid. And the volume is found by doing the following. 1/3 area of the base times height. This is the same for all types of pyramids, but the area of the base would change depending on the base of the pyramid. Then for cone, it says pi r squared plus pi rl, where r is the base radius and L is the slant height. Remember, this is the slant height, right? In this case, 5. And the formula for volume, and the radius, remember the radius is the distance from the center of the circle to one of the endpoints of the circle, right? In this case, the radius is 3 centimeters. Okay, and the volume for a cone is 1/3 pi r squared times height, where height is the perpendicular distance from the base of the cone. Okay, in this case, the height is equal to 4. Pay attention that the height is not the same as the slant height. They are different things. Finally, for sphere, the surface area formula is 4 pi r squared, and the volume is 4/3 pi r cubed. We're not going to see the demonstrations of all of these formulas because that corresponds to a previous knowledge already. Okay, so let's see this example. It says, find the volume and surface area of the cone. So in this case, we have a cone, so we're going to apply this to find the surface area and the volume. So first of all, we're asked for volume, so we're going to write volume. Before actually doing that, I'm going to identify my information. What do I have? I have that the radius, first of all, is 3 centimeters. We have that the height is 4 centimeters. And that the slant height, L, is 5 centimeters. So with this information, I can find volume. The volume of a cone is this one over here. All of these formulas, just for you to know, are available in the formula booklet. If you go to the first part of the formula booklet, where it says prior learning, you would see that here you have all of the formula. In this case, we're using cone, right? So let me see, volume of a, I think it's down here. Wait, geometry and trigonometry, here. Yes, here you have volume of a right cone and area of a curved surface of a cone. So it's actually in topic 3, okay, geometry and trigonometry. So if we go back, we're going to use the formula. We're going to see that the volume is 1/3. 1/3 times pi times radius squared, that's times 3 squared, times height, where the height is 4, right? So if you solve for this, you're going to get the volume. This is, we see that we can simplify, for example, 3 with 1/3 here. So this is pi times 12. So this is 12 pi. We're talking about centimeters cubed when we talk about volume, okay? So that's the volume of this figure. Then we're asked to find the surface area. So the surface area is given by, for the cone, this expression over here. You see that it's the area of the base. The area of a circle is pi r squared, right? So it's the area of the base plus the area of the curved surface area. So this pi rl corresponds to the area of all of this lateral part of the cone, okay? So let me write the formula here. It's pi r squared plus pi rl. Pi rl. So we're going to plug in the information. Surface area is equal to pi times 3 squared plus pi times 3 times 5. Okay, so then we get the surface area. Surface area, which is equal to 9 pi plus 15 pi. And if we add this like terms, we're going to get that the surface area is equal to 9 plus 15, that's 24 pi. 24 pi, and this is centimeters squared because we're talking about area. Okay, so that's how we find volume and surface area of a cone. We need to have this essential 3 pieces of information in order to be able to solve. Okay, then it says find the surface area and volume of the following pyramid. We're going to see how this applies for pyramid. So it's actually the same thing. For a pyramid, well, in this case, it's a square, not a square pyramid. It's a rectangular pyramid, right? Because the length and width are different. So let's work with the surface area, which is a little bit more difficult in this case. To find the surface area, I will have to work with, you see that we need to add the base. So let me write this as area of the base, area of base, plus, and we need to add how many faces, triangular faces do we have? 1, 2 in the back, 3 here, and 4 here in the front. So we have four lateral areas. So we're going to write plus 4 times area of a triangle in this case. Now to find the area of that triangle, we need to do something, right? To find the area of a triangle, remember the formula is base times height, and height is this one over here. So we will need to find this height by working a little bit with this triangle over here. Okay, so we're going to be working with that now. So if I write this in words, before we actually plug in any numbers, we're going to say that the base is a rectangle, so this is length times width, right? And the triangle, this is 4 times, and the area of the triangle is base times height divided by 2. We already have the base, but we do not have the height. Okay? So to work with the height, we're going to draw, we're going to do the calculations here. For example, we can say that this side over here must be equal to half of 9. Half of 9 is 4.5, right? So from here to here, we have 4.5 centimeters. So then, if I work with this right triangle over here, we can apply the Pythagorean theorem. Let me draw that triangle. There's a right triangle right here. So we can find this side by applying the Pythagorean theorem. We're gonna say that this is the height of the triangle, right? H. So we're gonna say that h squared, remember Pythagorean theorem, is hypotenuse squared equals side squared plus the other side squared. So if we calculate h, well, h squared would be equal to, this is 25 plus 4.5 squared. This gives us 45.25. So if we take the square root on both sides, square root and square root, we're going to get the value of h, which is square root of the answer. We're getting, let me write the whole number, the exact value. It's the square root of 181 over 2, okay? This is centimeters. This is the height of the triangle. So with this information, I can calculate now the surface area. So we're gonna say that, let me draw space here. We're gonna say that the surface area is equal to, the length is 9 times the width is 7 plus 4 times the base, which is 7, times the height, which is square root of 181 over 2. And by doing all of this, we're going to find the surface area. So the surface area is equal to, let me see, 9 times 7 plus 4 times 7 times, I forgot something here. It should be base times height divided by 2. There. So then we're going to have the surface area, which would be equal to this number, 157.2 centimeters squared. This is the surface area of this particular rectangular pyramid, right? Now we need to find the volume. Let me do a volume here because this is actually shorter. To find the volume of a pyramid, of a rectangular pyramid, if you remember from the formula I have here, it's 1/3 base area of the base times height. So let me write that here. It's 1/3 area of base times height. So we have all of this information. This is the area of the base and height. So the volume would be, in this case, 1/3. The area of the base is length times width, so that's times 9 times 7. And this is multiplied by the height of this rectangular pyramid, which is 5. Okay, so there we have the volume. So the volume is 3 times 7 times 5. 3 times 7 times 5, which is equal to 105 centimeters cubed in this case. Centimeters cubed. Okay, so there you have the volume and surface area of this rectangular pyramid. Finally, to finish, we're going to do this exercise. It says find the curved surface area, the total surface area, and the volume of this hemisphere. So, in this case, as we are said, this is a hemisphere. Hemisphere is half of a sphere, right? So let's identify our information here. Actually, the only thing we need for this example is the radius, right? Which is 3 centimeters. If you remember, from the formula we had for a sphere, this is the surface area formula, and this is the volume formula. So let me write this here. Surface area of sphere, surface area, I'm writing like this, sphere. So of a complete sphere is 4 pi r squared. And the volume of sphere, of the complete sphere, is 4/3 pi r cubed. Okay, so if I want to find the curved surface area, the curved surface area would be only this part over here, the curved part. We're discarding this part over here because that's not the curved surface area. So if we want to work only with this, the only thing we need to do is use half of this value. So it's this formula divided by 2, right? So let me write that here for part A. Curved surface area is 4 times pi times r squared. R is 3 in this case. And this has to be divided by 2 because we're talking about a hemisphere, half of the area. So if we calculate this, we're going to get as a result, right here, this would be 9 times 2, that's 18. 18 pi centimeters squared. There you go. Then for part B, it says the total surface area. If I want to find the total surface area, I already found the curved surface area, but to find the total, I need to add this area over here. So it's basically, let me write this as total surface area. Total surface area is, let me write it like this, the curved surface area plus the area of this circle over here, which if you remember the area for a circle, it's pi r squared, right? So the total surface area is equal to the curved surface area, which is 18 pi, plus pi times 3 squared. And this is 18 pi plus 9 pi, and 18 plus 9 is 27, right? 18 plus 9 is 27, so the total surface area is 27 pi centimeters squared. This is the total surface area. Finally, for part C, it says that I want to find the volume of this hemisphere, okay? So the volume of the hemisphere would be half of the volume of the sphere, right? So it's actually 4/3 pi r cubed, and this is all being divided by 2 because we're cutting the sphere in half. So if we plug in the information, this would be 4/6, right? 4/6 pi times 3 cubed. And if we solve this, we're going to get the volume, which is, this is 2/3 times 9. We get 6 pi centimeters cubed. And this is the volume of this hemisphere. Okay? So that's it. I think this is quite easy. It's just applying formulas which are available in the formula booklet. You don't need to memorize none of these formulas. So I think it's pretty easy. And okay, that's it for today's class. You're going to be practicing with some exercises later on. And please let me know if you have any doubts. See you.